Welcome everybody to a little bit of good old edutainment on CDCO home construction and utilities tonight. Pumping straight from Factory Farm in scenic Maysville, Missouri. Alright, let's talk about utilities for the CDCO home, and I'm going to base this presentation on what we've already done with the CDCO home version 1 back at the Kickstarter 2016. Now we started all the crazy utility stuff. And in the CDCO home, the actual builds, what we're doing is using every build to innovate. So already the photovoltaics are a standard feature on the house. It's like we're not building a house without that. If you want a house without why wouldn't you want a house without photovoltaics? Everyone loves that. Photovoltaic panels are dirt cheap right now, approaching zero marginal cost. But if you notice, PV systems that you get installed for a house actually have not really gotten down in price, which is actually quite crazy because it turns out that most of the cost of a PV system is now labor. And it's the comic inefficiency of different trades retrofitting solar systems on homes, and it becomes very expensive. So if you build from scratch, know how to do it. If you're a DIY builder, you can really crack the costs on that. But also, if you're doing an enterprise like the CDCO home from scratch, you can design that into your house, so therefore you make it very efficient and you design everything from the ground up, and that makes it good. I'm going to share my screen and I'm going to go into some entertainment about the utilities, because I'm going to turn this into some jokes, as in expanding your index of possibilities, because I want to put all kinds of crazy appliances eventually into the house, such as thermal battery and other things, as standard features, and eventually to crazy things like, what about a solar hydrogen appliance? You put enough PV on your roof and you've got an electrolyzer, and that's generated with a universal power supply and a global village construction set. You got water from the water well drilling rig or rainwater collection, and you can generate hydrogen. It sounds far out, but I personally believe that's kind of inevitable as technology gets better and open source. Like right now, you don't have any open source electrolyzers or system integration that allows you to do this, but that kind of crazy stuff is possible. So let's take a look at what we've done before.
Marcin, are you recording?
Absolutely, this is priceless. Okay, sharing screen. I'm gonna blow through this presentation. Can you see my screen now? And just say so.
Yep.
Okay, good. Okay, so this was CDCO Home 1, Open Building Institute 2016, and this is the kind of stuff we were doing. We originally said, okay, 3,000 watts of solar panels, super efficient LED lighting, rainwater catchment, yeah, that's great. Compressed earth block walls, hydronic heating under radiant floor made of compressed block. We actually did implement that. There's biodigester, PV inverters, gray water gardens, sand filters, plumbing panel that allows you to feed a biodigester, separating toilet, which we have done. But okay, you got PV, you got good thermal performance, you got things like a pellet burner. All right, great. But let's add a few more things after we're done with this. So let's add a few things. And here I'm actually going to kind of more like entertain you with the kind of crazy things that you can picture as extreme applications of what, like, your house turning into a productive system. So if you talk about production, a garage microfactory, okay, imagine this. You've got 3D printing in metal, plastic, and and 3D printing in metal, plastic, and circuits. And you got just about any appliance on Amazon. What's any appliance? It's got plastic, it's got wires, and it's got circuits and some components. But in a most reduced sense, you can, if you have open designs, you can do a lot of this in your garage. Now for real, like, now these machines would have to be super advanced. And we're not talking about just some 3D printer in plastic or like little circuit mill, but something that would have circuit milling, pick and place, tons of components to select from, etc. But why do I say 100x Amazon? Because anything we buy on Amazon, like for example, a great classic is an ozonator. Here in factory farm use, they last like 3 months or 6 months. When we buy one, it's just insane. So this is called a lack of lifetime design. If you build it yourself, you have 100x value because you gain 10x from more value. Wait, where's the other 10x come from? Open design. I don't know, but it's at least 10x by open lifetime design. There you go. Okay, let's talk about other things. So instead of the where's our plastic pyrolysis appliance for fuel under the sink? Oh, there we go. What is that? So if you take plastic, okay, so this is exciting. Plastic, there's a lot of plastic waste in a home. Imagine you shred it up and then pyrolyze it in a machine that fits under your sink, and then you got fuel. So you got your pipeline to your gasoline or diesel. Now this is quite realistic, like pyrolysis of plastic. Plastic is literally fuel in disguise, so you can do this kind of stuff. Okay, well, let's continue with some other things. Open source desalination appliance. So 3D printing and advanced filter elements that are used in reverse osmosis. If you do that, you can put your house in a desert in Africa next to the sea, and you can get fresh water, or you can desalinate at scale. Now, I kind of joke about it, but actually, I just went through some numbers on desalination, like the filters in there. And because we're actually working, so Eduardo with the apprenticeship, who's actually one of the people signed up in an apprenticeship, he's got a farm operation. He needs to desalinate water that's underground because underground water is brackish. So we're talking about 3D printing appliances, basically a desalination plant, meaning that you do all the housings and pumps and you buy the filter element off the shelf. We certainly don't have that kind of technology to make reverse osmosis membrane in-house, but if you do that, if you look at the price of a desalination system at farm scale, it's like a few million. But if you look at the actual, we looked at a $1 million reverse osmosis desalination plant, and the actual cost of the filters there is about 100K. Everything else is balance of system. So if the sensitive component is 100K, we can get close to 100K or 10x cost reduction of desalination, which would be absolutely awesome. So great, we got water anywhere. Okay, let's talk about the metal appliance. Once again, shredder, induction furnace, then metal rolling, and wire and rod mill. And when you see these icons, I'm actually like, these are all machines in the Global Village construction set, but for your metal appliance, put that next to the pellet burner, and you're making, like, what's the power in there? You take aluminum or steel cans, you induction furnace melt them and then roll them into wire or fresh metal that you can use. Okay, cool. That is actually like, you can think about a smaller scale system that you can do things like, just think about all that those metal cans or other metal stuff that you want to shred up and then reuse. Okay, let's talk about a biodigester. So actually, biodigester, that's there are some systems that resemble biodigesters that are actually code approved and where people use septic fertigation. In other words, dripping the effluent from it's called they call it a septic tank, but you can drip that through even on small lots, like on I think even like half-acre or quarter-acre lots, you can actually do that where you're pumping the water out of that system into the ground. Now, what's it look like? This is actually a picture from CDECO Home 4. Hey, that's your biodigester. That's the start with a toilet, and then you go into biodigester totes. This is what we actually built in CDECO Home 1. That's an actual functioning biodigester that we then sent the effluent just down on the land. We never collected gas, but that's something that's definitely doable. And what we are going to do in in the workshop itself, this has got a hyperlink. So for the hangar, we're planning on this thing. So we're going to build like in the next week, literally, we're going to build a system that's got a toilet. Let's see. I want to go to hangar real quick. Hangar build instructions. But what we're actually going to install there is a thing that looks like. So this is under construction. If you saw the title screen of the last video, you saw the big walls coming up. But we're in process on that. Today was rainy, but that's what we were doing. This hangar stuff, laying the walls on the ground and then tilting them up, which is good for super large structures if you have a telehandler to lift it up. But look at this for the toilet. What do you got? We're going to do a 10 by 12 room in one of the bays in a hangar. So you can get a regular toilet, but I'm not talking about a regular toilet. This is actually a super toilet. So this is actually what we got. It's a dual flush that goes between half a gallon to 0.95 gallon. So this is the most 0.5 gallons per flush, which certainly is viable for urine. I mean, you might double flush if you got number 2, but so you use the 0.95. But look at this, 0.5. You're talking about for the workshop itself. I ran through the numbers for the number of people. If say we got 50 people during the workshop, we're talking about saving tens of thousands of gallons if we do like 0.5 per flush, as opposed to an industry standard of like 1.3 gallons. So we're using this toilet with a macerator pump in the back going then into biodigester. So what are these macerators? So these are these kinds of things. You can get them on wrong link. I want one that's actually that has a bottom drainage. Just got it. Bottom. So you can put this, you can put your toilet, and then right behind it, even with a bottom flush toilet, like a regular toilet, not a side exit toilet, which you can get for basements and things. Here's a regular toilet on a small pedestal. So actually I can just drop that. You need like 8 inches rise, and then you go into that lower. I'm gonna get rid of that one and put this one in, with the key being the bottom entry on this macerator that sends your poop against the law of gravity uphill, such into a biodigester totes or something, where if you're in a basement you can do this. But this basically allows you to not dig under the ground, which simplifies this. This allows us to do the utilities in a hangar real quick, do a makeshift bathroom. This kind of a macerator pump has multiple entrances, so you can have showers, sinks, and other things. The exit goes up, but you've got four total of 4. So this is the big hole is for the toilet. The other ones are for showers, sinks, and everything else that you have. Okay, so that's utilities. That's the biodigester thing. Let's go through some more systems here. Aquaponic greenhouse. I mean, that's actually. Did you know that in a 700 square foot aquaponic greenhouse, and we've seen this kind of productivity in the CDCA home, it was actually the greenhouse in front of the micro house on site here. The growth rate of tilapia we had about 1,000-gallon pond in there. The growth rate is like 1%. So from 1,000 gallons, you get a pound. The numbers turned out to be like 2 pounds per day in the actual growth rate of the tilapia themselves. So aquaponic greenhouse technology is extremely powerful, especially if you could do things like take the biodigester effluent and use that to feed the plants, and the fish poop feeds the plants. So you have a closed loop system with very high productivities that are just insane. I'll show you a couple of pictures maybe of the actual.
Well, you need you need an exhaust port for your gasifier and your pyrolysis unit.
Yeah.
It's going to be carbon dioxide.
Oh yeah.
But it has to be clean carbon dioxide for greenhouse.
Okay. Yeah. So you're saying you're suggesting further integration?
Yeah, but that's what we were thinking too. Is when we were thinking of our gasifier system. We were thinking of pumping into a greenhouse, but it does. Greenhouses do require clean carbon dioxide, but it's an excellent idea. Especially you might even generate dry ice from it and then use that in your greenhouse, which is what greenhouses do.
Yeah. And dry ice. Now that's some heavy duty. If you talk about refrigeration, that's these. Much more high-tech compressor things, right? But still, like if you think about a basic concept of GVCS. Okay, so there's a thing on the wiki called GVCS icons, and I encourage you to play with this. But basically, if you look at any kind of a device, where's my icons? GVCS icons. If you look at, so for example, dry ice, that's like some crazy technology, right? But what would it be? In essence, I'm like trying to simplify this to the dumbest way to present it, but you got electric motors in a set, Okay, these are hydraulic motors. These are like, where's my electric motor? It's right here. But a compressor that's got the grade to go to vacuum that's required to do dry ice. That's a, these are fancy compressors, but they still have, so you can think of, here's a electric motor. You've got some CNC machining to make some precision vacuum elements and so forth. And there you go. You just kind of like bootstrap to a next higher level of technology, especially if you can use this construction set to produce technological recursion, meaning you can actually bootstrap to higher levels of technology using simpler technologies. Just saying, that's a concept. But let's look at the favorite for everybody, the PV. So this is what was the build in the actual last house. We're going to do this kind of an install in a CD, the build in December. So it's an inverter. You've got an indoor breaker panel. You've got the DC disconnect, and then you got an AC disconnect because this hybrid inverter gets topped up by the grid if there's not enough sun. And there was a transfer switch so we can operate fully on grid or fully off grid. That's the kind of thing. I want to show you the history too of what happened. We start with a 3 kilowatts on the CDECO Home 1 with a greenhouse in the front. This is CDECO Home 4. Same size, 6 kilowatts. CDECO Home. So this is under construction. This is like a few weeks ago. This is actually under construction of the 720 square foot structure. That's as being finished on another site right now. But that's what we're actually. This is what the system is going to look like, and what we'll do for the actual workshop. Since the hangar is going to be 14 feet, you're not going to be able to stand on top of the roof because the roof is going to be like a couple of feet. The house roof is going to be like a couple of feet from the ceiling of the hangar. So what we'll do is we'll make this entire roof assembly on the ground, and people can actually walk safely and connect things together. And then we're just going to telehandle it up to the house. So when we're going to be building the house, we're going to be, you can kind of see the 3 sections here, but these are like the 3 sections of 12 by 20 that will be built at the same time, and we'll spread that throughout the hangar, people working on all the different things, and then we're going to finally like push them together with some machines and lift up, because we have access to the machines, and we want to basically do everything radically modular, just like, for example, with a heat pump. We can install it as a separate module without the house being built, so we have like this controlled environment, and we install that module into the house because we left a framed opening for the heat pump itself. Okay, so let's talk about some further questions here. Geothermal loops. Okay, what do we do for geothermal? So if you Google, okay, this is for active development, but if you bury a line that's 8 feet deep in the ground, and that's heavy digging, like 8 feet deep, that's a lot, right? But if you do that, then if you have a heat exchanger inside the house, then you can use that to cool your house in the summer. Now there's also the issue of that almost does it, but there's the issue of latent heat. The idea that you don't really address the humidity unless you condense the humidity out of the summer air. So you would still need like maybe a tiny air conditioner while you're running the bulk or any dehumidification means. You would need a dehumidifier if you were to run a ground loop of geothermal, and I mean true geothermal, not where you are using a heat pump to connect to underground loops, and then you're heat pumping that heat or cool with a heat exchanger into the ground. No, I'm saying no heat pump, just the cool of the earth, which is like 60 year round at 8 feet under. So that's a thing to do. We can try to now. Digging 8 feet is hard. You need some bigger machines for that, and that's why these things are pretty expensive. But if you go down to 4 feet, you get a lot of that benefit, and you will still get the geothermal cooling most of the year. Maybe like towards the very, very end of the summer, it might start warming up. But we're going to explore like what are the limits of that and how we can actually optimize that so it is doable with, like, I pay attention to things like 4-foot trench, because that's something you can do with like a 50 horsepower small machine. For 8-foot trenches, That's like, you got to take out the backhoe and it's really slow digging. 4 feet, you can very easily trench with a small trencher, like on a skid steer. For 8 feet, you need a pretty large trencher. Like, they don't make like 8-foot trenchers for skid steers. That's a bigger, higher class machine. Okay. So that's geothermal stuff. Now for thermal battery, this is our cunning plan. So actually what we're going to do is we're going to build a separate 10 by 12 building module that's attaches to the back of the house, where we're going to put a bunch of biodigester totes where we're just cooling and heating the water in there up to 120 F and down to whatever cooling temperature is, like whatever the heat pump puts out on the cold side, so that we can heat exchange it. We can heat in the winter, cool in the summer. Now, here's the trick though, and this is an insight for how to do this. The heat pumps that go from air to water, like that cool water, I mean, there's heat pump water heaters and water coolers. Those are expensive though. So if you wanted to heat a house, the affordable option is an air-to-air heat pump, but then convert it into water heat exchange. How do you do that? Our plan is exactly this. Let me show you Chat GPT of what we're trying to do. So I just asked it, because I'm asking, okay, how about we just break it? I say to Chat GPT here, I'm like, for a thermal battery with regular air-to-air heat pump, and why? Because those you can get for $1,000 for 24,000 BTU. So you're exchanging heat into water. How do you do that? You got to cut into the hot fluid lines. I mean, you can literally blow the hot air out of the heat pump, but that's going to be an inefficient exchange into water. Like, you can do a blower and do an air-to-air heat exchanger, not as efficient as if you say broke into the hot fluid line, that's doable. All you do is you cut the lines. You have to put fittings on the lines. You get some copper coil from Menards or Home Depot, like 500 feet of copper coil. It'll cost you like a few $100, maybe $500. And then you're running that hot. You close that system up. You have just created a heat exchanger that goes into that heat exchanger submerged in the tote. So you submerge this copper into the biodigester tote. Well, biodigester totes. I mean the same totes that we use for the biodigester. So I'm asking, well, why can't we just do that? Is it easy enough to do that? You might have to top off the refrigerant if you got as much as 500 feet of coil running off your pump, because the refrigerant lines on a heat pump they're like 10, 20, 30 feet long, typically. If you add more line to the system, that's going to decrease the pressure of the refrigerant inside, so you probably need to add some more. Now, adding more, that's a doable. We'll show you. We'll probably show you how to do that in the course here. But basically, basic operations: how do you evacuate a heat pump so that you can release the refrigerant that's already in part of the heat pump, or add more refrigerant? We can show that. But I'm saying here, hey, why don't I run a copper coil, just as I described? We can produce a heat exchanger. So isn't this straightforward? DIY build, say you're in a condition of no inspections. To get this into an approved system, of course, you would have to get this certified and engineered and so forth. But if you have no inspections, if you can do this, isn't this trivial? Or are there challenges such as it's super difficult to like build or make this heat exchanger work properly? So the answer is, the idea is simple, but the details will bite. So what's the why? Yes, you got high pressure in the refrigerant lines. Yeah, you got to do it properly. Not a big deal if you do I'm not going to do any brazing. You're using fittings. You're using flange. They're called. We're going to do that in a workshop. We're going to create fittings we're going to cut in a heat pump install. We're going to cut into the lines to get them to the exact correct length, so that they will look like. So I want to show the heat pump. They will look clean. I don't have it here. But basically, a nice clean heat pump install means that you don't have like a whole bunch of loops of coiled up extra tubing, like some DIY installs do, you can invest simply in a little cutter for metal, for copper pipe. It's a very simple device, costs like 20 bucks. And then you have to put flare fittings using a flare fitting tool. That's also like a $50 device tool. So no, we're not going to braze. So we definitely can handle the pressure. So the oil return is the real gotcha. So that's the thing. No dips and this is actually exactly the issue that you got to watch out for. The idea is no dips where oil can pool, because the heat exchanger, the heat pump, has got lubricant in it. There's oil in the actual compressor. So if you do not design this right, meaning that you have some low spots in your heat exchanger, then oil will pool there, and you'll break your compressor because it doesn't get lubricated. So the thing to do here is you must make the system such that the actual pumping of the coil could be a spiral going up, so that any oil that goes into the fluid lines actually drips down back into the condenser of the heat pump. In other words, the big challenge here is, well, your heat exchanger has to be above the heat pump. Okay, can we do that? Yeah, sure. Why don't we stack two IBC totes, the totes like you saw in this picture. Just stack, do this. Here we go. Here are, where's my digester picture? I think it was up here, way up here. Two totes high, they do that. You put the heat pump lower and you put the heat exchanger into the top IBC tote. This is showing the biodigester. We would do a different system for the heat pump, heat exchanger. Now that's, let's see if we have any more, if chat tells us there's any more trouble. So the oil return is a real gotcha. Hey people, I just told you we solved it. We just put it in, put the heat pump below the container, which has the heat exchange water. Water is our working fluid. So you've got the copper coils with the whatever R432 whatever refrigerant, and then you got that submerged in a tote full of water, and there you go. So all you got to do is make sure when you penetrate that through the tote with the copper, yeah, that's, you probably want to cut out the top of the IBC tote. You submerge your coil in there. You feed the coil through an opening using what I would do is a uniseal. Uniseal works, uniseals? This could work. Images. Uniseal. These are designed for copper tube size. And what are we using? We're using copper tube. So you can fit one of these through you can make a clean penetration through the side of the biodigester, and this should in principle work. So that's our cutting plan for the heat exchanger pump. Now,
I've done that before on an IBC tank. Do you have like a nice Dremel tool with a rotation tool attached to it? You need that to get an exact hole.
Yeah, we've got yes, we've got high quality hole saws that will do the job. They're quite clean, and you can also chamfer the edge as well with another tool.
Okay. I made way too many mistakes initially doing that.
Yeah. So let's look at. So this is our. We're farmer scientists here. We gotta do all these steps. Okay. So another thing, charging isn't a top off. It's a full recap. Yes, you have to know what you're doing. You gotta take measurements, and you gotta have a little refrigerant scale to measure how much you're actually putting back into the system. Water heat exchange. If the water temperature gets too low, you create condensation too early. If the coil is too hot, you're not getting much energy. So we got to pay attention to details like what the temperatures are and things like that. It's not just cut and braze. You got to kind of know what you're doing, but we're going to do it anyway because we're learning. Now they have a suggestion, the clean way to do your thermal battery. De-superheater coil. Yeah. So additional components, and maybe adding a secondary coil to the heat exchanger, plate heat exchanger on the liquid line. Yeah, I mean that's the easy way to do it. Except instead of cutting into the hot gas line, they're saying take the high pressure liquid after condensation, run it through a small brazed plate heat exchanger and warm your water. Yeah, cool. That's cool. As in, okay, however, we're talking about 24,000 BTU of heat exchanger. We want to take, that's good for maybe a smaller system. I would go with direct coils, which are much more efficient, I would say. Now, final verdict, builder to builder. You're not crazy. Yes, you can redirect hot gas into the water coil and make a thermal battery charge itself. And yes, many DIY heat pumps hackers do exactly this, but it's not standard because all return, wrong coil geometry, too much water cooling, blah, 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 brazing mistakes, wrong charge. These are all technicalities, but we got it tight. Is it doable? Absolutely. Is it trivial? No. Okay, there you go. So that's the discussion on that. Now let's top this discussion off here since we're at about half hour. What else? What else do we want to do? PV supersize gets you solar hydrogen. Thermal battery, geothermal, plastic pyrolysis, aquaponic greenhouse, desalination, gray water garden, hempcrete block. Oh, that's a great one. So we have to get into solar concrete appliance. If you have a lot of PV, you can burn rock and turn it into lime. That's called concrete. So let's do a small device for entertainment, which gets us production rates, production grade concrete. You can look at some calculations of how much power you would need for solar concrete. Solar concrete simply means using solar photovoltaics instead of using electricity or no. This industry standard is heat using fossil fuels, probably gas heat or coal heat. But the numbers are for solar concrete. The bottom line is you need 1 kilowatt hour per kilogram to make concrete from rocks per kilogram of cementitious material like lime. Think about that. 1 kilowatt hour per kilogram. That's pretty good. So you got a 6 kilowatt in a standard model of the Eco home. You could make 6 kilograms of cement per hour. That's not bad. In a day, you get 36 kilograms of cement from your Eco home photovoltaic panels. That's like a bag of bags of cement mix are probably like 100 pounds maybe. So you get like a third of a bag of cement mix. That means you multiply that 5 times after you add water and rock and sand to it. So anyway, those are the bottom figures for your entertainment. This is for educational purposes only. Okay, hempcrete block. Hey, if you got the concrete, you can grow hemp in your gray water garden and make hempcrete block in addition to the compressed earth blocks, which are the compressed earth blocks are actually quite a formidable technology. We're not doing it yet because while we built most of the buildings on site with compressed earth blocks, it is hard. You got to have some serious equipment to do that. But it's actually, I want to explain CB, like what's the feasible route? Like for example, if you do not stabilize with cement, it's absolutely trivial. You take a soil mix, like pretty much a soil, what do you call it? A rototiller, which we did in the GBCS. We put the tiller. Tiller is one of the machines, and a tiller is effectively this is your tiller there. The tiller is effectively what we used as the soil pulverizer in our Civilization Starter Kit V001 version, but it works. You just do a rototiller to break up clay soil, and you throw that into the compressed earth block press, and you make compressed earth blocks. And the production rates are insane. Like we got up to 10 block per minute on 50 horsepower, because our machine can take up to 50 horsepower easily. 10 block a minute. Hey, that's pretty cool. So but it's unstabilized. So if you get a rain, your walls are going to collapse. If you're doing the build process and you get a thunderstorm, your walls are down. Sorry, you got a mud pile. So one feasible route, and it's certainly doable, is you put the roof on first, like roof structure, and then you build the walls from underneath, which is completely feasible. Or even taking a lightweight framed, 2x4. We typically use 2x6s, but say lightweight frame it 2x6s, just to hold the roof up, and then you actually do the walls with CB produced at 10 block per minute. Hey, we've done that. CDCO Home 1 and 2, we press the block right there, and it works. In a day or two, you press all the block for a small house. And if you take it to industrial scale, where you got full 50 horsepower per machine or multiple machines, you can talk about a full CDCO home, like 1,400 square feet, all the brick pressed in a day, even for the floor too. So 5,000 block per day. Hey, that's real. That's in a TED Talk. So what else? Metal. Wire. Oh, wire. Wire is a complicated thing. Today we just got a coil of 4/0 wire for the hanger. But what is wire? Let's see. What's wire? Wire is from the metal appliance. So if you've got metal that you shred and then melt and then roll, or wire and rod mill, you pull the wire. Actually, with I didn't put this here, but if you take now the bioplastic extruder and run a metal strand that you generated from your wire and rod mill, and you put an extrusion of plastic around it, that's how wire is made. Wire is actually, you pull a strand of metal through a molten pool of plastic. So say you get like a plastic coated wire, which is what you get from the store. Well, you can modify the extruder to generate filament, like effectively 3D printing filament with wire embedded in it is a wire. It's really a conductive wire. So the same kinds of machines that you use for bioplastic extrusion. So the bioplastic extrusion is one of the machines in the Global Village construction set. The same tech applies to both 3D printing and making wires, so you can wire up your house with fat electricity from the sun. So that's that. Let's see, anything else to cover? Aquaponic greenhouse, we've seen this, we've done that. That's 2,000 gallons of water, heat exchanger of just PEX pipe inside of it, and 10,000 hazelnut plants being planted out, and a bunch of lettuce and chard and things. This is our so this is what we did. So you remember what I showed on this slide, this slide here, this device, a macerator pump. We built our own for CDCO Home 1. So this is like you get it from Amazon, and it might last a little bit, not lifetime design. We did this one here. This was, where was that? Where did I see that? This one. We built this, so it's actually, there's a macerator pump underneath it, and it gets fed from the toilet from underneath. So this was actually in a pedestal, and we currently have this actually. And this device actually allowed us to separate urine from poo by when you press the flush button. If you activate a pump, it'll pump it into the biodigester. But if you don't activate the pump, then it weeps through the red line here. It's part of a weep system where if you just flush without solids, that drains down the drain and not the biodigester. So this effectively turned a regular toilet, which sits above, into a regular flush toilet. Think about that. Regular flush toilet, either pee or poo in it, one hole, but this system actually separates the liquids from the solids. So that's actually pretty cool. Now the pump here was a weak link. After about 2 years it broke and we never replaced it. So this stands as an experiment that still is in our house, the house which I am living in right now. We did hydronic heating. We're not doing hydronic heating in this house, but certainly hydronic heating is a worthwhile thing, because once we have the thermal battery, what's the best way to do it to dissipate heat? Well, in-ground heating is a really pleasant way to do it. Warmth from the ground. But I'd imagine you could also do cooling that way too. If you run cold water through it in the summer, though the cold tends to stay down. So while for heating, a radiant floor is great, for cooling, you'd want a radiant ceiling. So there you go. Let's see. We were doing water collection. This is Civica Home 1. This was we dug a cistern for things like that, so covering some utilities. And this was actually, this was connected to our separating toilet. That was the gold water. That's called urine. We were actually going to save it for farm fertilization. And the other line we had for gray water and biodigester effluent and clean out, stuff like that. So we actually used and implemented the system. This was next to Civica Home 1. What else to show? Some water filtration. Not getting too much in that. I mentioned a little bit about the reverse osmosis, which is kind of a high-tech thing compared to just simple filters. But an RO filter is basically an advanced filter that looks like one of these filters here, and it requires a little higher pressure to pump through, and it's slow. It's like a slower dribble. Biodigesters, I won't get into that too much right now, but there's diagrams here. So. Simple, effective way, like if you want heating for we had this heat exchanger go into the pool water, so this is called the hillbilly heater. It's just black tubing, and in the sun it gets hot in the greenhouse, so you can heat water that way. We did a prototype of a thermoelectric generator. We put it on a stove, but since we're not running too many stoves right now, we switched a lot towards the heat pumps, so that's kind of a disused experiment. But let's celebrate. Let's have another party December 1. And with that, I'll take any questions if you got any. I'll stop presenting.
Oh, that was great, man.
Yeah.
That's really exciting.
Yeah, lots of exciting elements. We can definitely just keep pressing the envelope and see if we can make some of these systems work really well, and then improve their quality, so we actually release them as features in the house, which is, I'm not saying that lightly, that's a lot of work there, and that's what we're about. Yep. And this, I did save this and record this so we can publish this for anyone to review the crazy systems.
Yeah, I don't know if anybody wants to stick around. I think I cracked the code on the tech draw
okay.
kind of setup, so you can, maybe more easily. It's not super easy, but you can do nice drawings of the different components, right? So yeah, I don't know. Is anybody interested in seeing that? Okay.
Yeah.
All right. Let me.
So the idea is my request is take one module from the existing model, and show us how to do it in FreeCAD 1.
Yeah. All right. Yeah, that is what I was thinking. Okay, so let me share here.
Okay, so I'm firing open FreeCAD. Go ahead.
All right. Let me do my entire screen so I can actually.
Go ahead.
So I can switch between stuff. All right. So I was able to. This one, it's missing a few items in there, but this is coming straight out of FreeCAD.
Nice.
Yeah.
Wait, so this is unedited. This is all the views that you got from FreeCAD.
Yeah, this is the views that I got from FreeCAD. I was able to generate this .svg, and it's nice because it actually does the measurements for you. You can but there's a couple of steps to go through.
Okay.
This was kind of like the final result here, and I'll try to I can go through this with individuals if you want. So let's kind of start at the beginning. Let me do nope, that's not what I want to do. Sorry.
Quick question.
Yeah.
What was the deal with that scaling thing? Tell us about that.
Yeah. So, well, look, the models that we have, however they were built, FreeCAD has a standard scaling, and so the components that we have in our in our models are just like quite a lot larger than the default scaling, right? So you have to scale down everything when you're doing it. Let me, let's see here.
Was that scale factor the 25.4, which is the centimeter to inch thing? Or
No,
different?
it's just a straight up, we're going to go 10% the size of what we're doing. So, all right. So I have wall module 7,
Okay.
right, is the one I was working on. So let me just open that up. And you know what? Let me close this guy. Let's start over again. Save that. I wonder if it saved everything. Okay, let me.
You want to just walk us from scratch? From just
Yeah, I do. I do want to walk through from scratch. Let me. You know what I can. You know what I can do. Let me grab the wall module again. Off of the site. That messed up my demo. Sorry, guys. I wanted to. I didn't want to save that one. Okay, so no, that's not what I wanted. Wall module 7. Let me just grab it again from the
I mean, feel
from the
free.
website.
Just from scratch. You walk us from how you even go to the website. The
Yeah.
And
Let me share this.
Anyone
Let me share the screen again.
Yep.
Let's see here.
Because what I want to do is I want to follow your steps, and I want to notice if I get the same results, or even between, like, supposedly we even have the same systems. Are we getting
exactly
the same
exactly? All right. So actually, I want to go to. Let's just go to wiki. Let's go to SH7. And then let's see, the individual files are close to the build instructions.
They would, yeah, you could get them there. Yep. But I would go to CAD. The CAD would be the intuitive thing. Like, we should put everything, absolutely everything, including the big
files. FreeCAD, right?
Yeah. Item number 6.
Okay. All right. Great.
So there you go. 7.
Okay, and so this is just the best place to get it, right? I actually found it from the Google Drive itself, but yeah. Okay, so this is
the idea is that, once again, the development template, line number 6, line item number 6 is the CAD, so it's like, okay, it's on a wiki, so you don't have to remember anything, because you get lost in Google Drive and this and that. But okay.
Yeah, good. Okay, that's helpful. Okay, so I downloaded it. It's in my downloads folder. It's the new one. Let me open that up. Let me restart my guy. I'm gonna restart FreeCAD, and I'm gonna part design. Let me open up the model. Yeah, we're at the 1 here. Okay, and so what we have is the compound, and we can't actually do anything with this guy yet, right? So in order to be able to get the measurements for the different component, or for the different parts of this component, we actually have to break this apart. So the first thing that I did, and I'm going a little bit from memory here, I created a group in here. I don't know that this is necessary, but it was for kind of like organizational purposes. There's a group tab in here, and I think I'm selected here. Sorry, escape somehow. Sometimes if you find yourself in a tough spot, you go to a workbench and then you go back to your workbench. So go back to draft.
You want to go to draft instead of part?
Yeah, so I'm going to draft. Oh yeah, so what I did was I hit my little group icon, add a group.
Okay.
And what I didn't see before was there was a little OK button down here, right? So I hit the OK button and then it showed up. All right. So what I'm going to do is I'm going to put my component inside of a group.
Okay.
Because I'm going to actually do something with the component. What I'm going to do with the component is inside of draft, you have the option to decompose. Downgrade, not decompose, downgrade. So I'm going to downgrade this guy. Oh, and actually, when you downgrade, it brings it out of your group. You can just pull everything back into your group. Okay, so our group is the entire object, but now you can see that we have each individual component, or each individual item inside of our component that you can highlight now. All right, so it's not just one big grouped item.
Yep, exactly.
All right, so that's going to be important for us. All right, so next we can go into our where is it? Tech draw. All right.
Mm-hmm.
All right, so tech drawing. And here is where we're going to create our page that we're going to edit on. And so what you want to do is you want to start with insert page using a template. You can do a new page, insert a default page, but you might want to do a template. You might want to mess around with a template. For me, what I did here was I just did 83 as the page size. I did like blank landscape. Some of these templates are kind of nice. They give you like little information bars and stuff like that. But I'm going to start with a blank page. But you can do as many templates as you want. You can just create 10 templates. You can go through all of these and figure out what they all are.
All of these are stock. None of those you have generated yourself, right?
That's right. They're all stock, yeah. So that creates a page for us. So you can see we're back. Here's our wall module here, and here's our page. Sorry, I have the Python editor open. I can just close that guy. And if you do want to see Python stuff, you can go to View, Panels, Python Console, right? And every action you do gives you the Python command that's been created. So inside our page, we have our template. So from here, we're actually going to create, we're going to insert a view, right? So let's select our group, right? All of our components, and we're going to insert a view. And so here's our view. We don't see anything on the page. And that's because our view is super huge and you can't even see it, right? So in the view, we go into our data. Let me first apply this guy. And here's another tip too, is sometimes you generally want to refresh, right? So there's a refresh button up here. You can also right click on your object and say recompute, right? So you want to recompute your object just to make sure that whatever you did is actually going to apply. It's just something in FreeCAD. So in here, in our data, you can see we have scale type, right? So it's scaling to page right now. We don't want to do that. We're going to do a custom scale. Right now the scale is at 10. I'm going to put 0.1, and I hope that works. All right, so I didn't see anything happen here. I'm going to recompute. All right, and now it came up.
Oh, okay. So it just didn't recompute.
It didn't recompute automatically. So I haven't messed with refresh. Refresh might do it too. But if you right click on whatever you're doing and hit recompute, it should pop up. And so now we have a representation of our 3D object here. And I can just take that and move it. You can also use your X, Y's in here in the data. You can move it around where you want to. It also has a little label. So the label is in here somewhere. Label, view. This actually doesn't come out when you print it, so don't be fooled, by it. But I can just call this whatever I want. So this is remember this that little dotted area doesn't come out on the SVG. That's why in the web page, it's not popping up right now. Let me show you. That was the problem. So I thought I was going to get these little labels here on each of these guys. They don't come out when you do the SVG.
Yeah.
Or the image. All right. So I have this component, and what I'm going to do also is I'm going to import active component. And so whatever's on your screen right here, just the way this shows up, we can actually import that image into our file as well. Okay, so if you're like zoomed in too much, this is what you're going to get. If you're zoomed out too much, that's what you're going to get. So make sure that you frame it properly. You can always go to fit all, right? And make sure that it's actually fitting within the window that you're going to show. So if you go back to your page, right up here is going to be insert active view, 3D view. And so a lot of times when you hit a button, it doesn't do anything. Um, you can see it's like asking you to hit OK down here. Make sure that you're always seeing the dialog box, right? So if I hit OK, we get our little active view guy, right?
That's active view. What was the former view that you inserted? Just remind me, I forget.
Sure. So the main one that you're going to work with is this guy, this um, insert view,
Insert view, okay.
right? And and that can be any one of these guys, and we're going to pull a couple of those in just to do a measurement. But so you have your little image of your active view here. You can go in here and you can scale it up and down, right? So I have my active view selected. I can increase the scale of it. Right. So we got that guy.
Yeah.
All right. So let's get into so we know that in the middle, this middle guy, he's a solid piece, right? It's difficult to tell what's solid and what's not here.
Yeah.
So you actually have options to kind of change the grading here. I'm going to make the middle one a geometric hash in here. Okay, and so that kind of fills in the space a little bit. And then I know that there's boards on either side of it. So this guy, I'm just going to fill him in. Oh, again, I have to hit the OK here. It's asking me to confirm. So these guys, and what you can do is all of these guys, I want to make the same, I want to make them all the same color. I'm going to make the tops the same color too. Those are all the boards that are just facing us like this, that they're sideways. So I'm just going to give them a little hash pattern.
You're selecting. How are you selecting all of them at the same time? You're holding
Control.
Control.
Yeah, hold your control key and then you can click, and that's standard in FreeCAD. You can do that all over the place. So I hit OK, and now they're all shaded properly. All right, so that looks a little bit better. And now next thing is we just want to grab. I want to grab like the center bar, and then one of these guys, and then one of the top, and then we're going to do some of the measurements, right? So if I go back to my wall module, I want to figure out which one this guy is, the center guy, and he's the solid 007. Okay, so I'm going to go back to my page here, and I've got solid 007. I'm going to insert view, and you can see it's down here, I think. This guy, view 001. So you don't see anything. I'm going to hit OK. You still don't see anything, and it's because our scale type is page, and so we got to go to custom, and I'm going to give it a 0.1 scale.
Recompute.
And yeah, I'm going to recompute this guy, and he shows up.
Okay.
Hey, it's behaving. That's amazing. All right, so I'm just going to put him right here.
Okay.
And then I'm going to get one of these guys. I'm pretty sure this one is fine. Let's insert this guy.
Wait, so you're taking like an individual one instead of like selecting, oh, this is just the front?
Exactly, right? And that's so that we can do measurements on that.
Okay.
Okay, so now I've got another view that's needs the scaling again.
So is there a way to get the whole front, side, and top? Or no, there's no way to do that?
Yeah. Again, you can just like control click your different objects that you want in here and do insert view, and it'll insert them all, and then you can control click your different views and change all the scalings and then recompute them. Absolutely.
Can you show me a view from the top? How I insert a view from the top?
Oh, you're saying like, I just did. You want to see like this guy?
Well, I want a technical drawing for the top.
Yeah, technical drawing for the top. Yeah. How would I do that?
So you inserted view before. Can't you just insert view?
Yes, but I would need to insert. Yeah. I would need to rotate My top guy. My top guy is solid 003. So let's see, solid 003. I'm at my page. Oh, sorry, I had to hit OK on something. So solid 003. Let me insert this guy. When you inserted last time, yeah, it's huge, right?
Okay, yeah.
Basically, it takes up the entire thing. So let's scale him. Oh, you have to hit custom. I bet you there's a setting that you can change to do this by default, but I haven't found that yet. Okay, here he is.
Okay.
So, but this is just this front version, right? So it's not showing it from the top. And to show it from the top, I think I can do it. By the way, if you want to get rid of the like active view and view 002 and all that kind of stuff, you can right click in here and toggle frames and they all go away. All right. Okay, so for this guy, can I rotate him? I haven't played with this yet. I think I can rotate it. I think I can rotate this object to show it from the top, right? But right now I'm just showing it from the side. But yes, I do need to rotate it at some point to show it from the top. Let me
rotate it. You can't just do a view from the top. So like 1, 2, 3, 4, 5, 6. Just pressing 1, 2, 3 on your keyboard. Because that gives you the different views.
Oh, I see what you're saying. Yeah, but so we're not in the parametric part view. We're in the tech draw workbench. We're not in the part the part design workbench. Yeah, obviously you can change your isometric views in here, but tech draws, I think it's slightly different as far as the tools go. You might be right. Maybe you want to play around with it. Let me show you really quick though. Let me show you the part where we're gonna here. I need to toggle my frames again so I can move stuff around.
Man, I'm just commenting. This is insane. Like they call this an improvement over FreeCAD 16.
Yeah, they did some cool stuff. By the way,
I mean it's powerful, but oh man, it's curve.
Yeah, 100%. All right, so I want to insert my dimensions here. So I have my insert dimension section here, and so I'm gonna pick. If I picked like the center, it would do an area dimension. So I want to pick the sides, and you might want to zoom in to help yourself out. But if I pick a side, you can go in and out. Tells you the exact size, and then I think I need to let me zoom in here. There we go. I'm going to pick the bottom. All right, so that's our width. Same thing for our sideboard. It's obviously the same exact size. And then we'll do our width down here.
Yeah.
And then we'll do our top board. And the side. All right. Wow. So that's pretty cool. Some of the other stuff that might be really interesting is you might want to label your different pieces.
Yeah.
Right. So you have you have a little bubble insert balloon annotation object here. You can actually. So I'm going to label this piece number 1, right? And so I'm going to annotate this guy, and that's piece number 1, and I want to show the same thing over here. So I'm gonna bubble this guy and do and so it's showing a number 2, but all I have to do is go back over to text, so I have it selected. I can change the text to 1. All right.
Okay. So can you actually type stud or
yeah, so let's do each of the sideboards. Okay. So the sideboards I'm going to label 2s, right? So these guys, the ones that are angled to the side, I'm going to select this guy. I can drag him around so he can be in different spots. All right, so I have him selected. When we're in the data for him, you'll see it's there's balloons in here under the views. I'm just going to label him 2. All right, and then I can go in here and I can control click my guys. Actually, I don't know that I can do this, so let's experiment and see if we can. So if I control click my guys, yeah, too many objects selected, so you need to do one at a time. But I'm gonna balloon select these guys, and I'm gonna label them all. So these are all 2s, and it's not necessary because these boards are all the same, I think. But you know, if we have lots of different ones around, it might help to know what we're talking about.
It helps to, I would say, just all the bubbles you're just itemizing, so
exactly
check them off from your cheat sheet.
Yeah, exactly. So this and also, I mean, you could do order of operations and stuff like that. I'm not sure.
Oh yeah, that would be
exactly.
Yeah. That would be cool. That's actually. Can you do multiple annotations in the same one? Yeah, sure, right?
Yeah, absolutely. Yeah, and there's different annotations that I haven't played with here. There's also labels that I couldn't get to work right. There's insert, just a generic annotation.
Yeah.
Oh, this guy. I moved this guy instead of inserting an annotation. Hold on. Let's see here. I'm not quite 100% on inserting annotations yet.
Okay.
Annotation is larger than the page. Will be scaled. It's like the annotation needs to be scaled down. Oh, here it is. It's somehow I got the annotation. Okay, there's 3 annotations on the page. That's very interesting. Let me get rid of some of these guys. All right, so the annotation, the text instead of default text, Wiggins here. Well, that didn't take, did it? Somebody needs to figure out how to use annotations.
Yeah.
But
with text? Can you change?
But basically, yeah. Well, basically, you could use the text bubbles, but I think annotation is good because then you can have a section where you're actually describing the file or putting parts and stuff like that.
Show me a bubble with text.
Oh, any one of these guys. So if I select this guy, I can put my whole name in that bubble.
It gives you the big. Oh, okay. So it gives
you the big it's bubble. Just not.
Oh, okay.
You probably don't want to use it for that, just because it doesn't scale very well. But if we figure out how to use annotations or something like that.
Well, you could use that for another purpose, which is to emphasize the importance of something.
Yeah, absolutely. So let me show you. So this is just a very basic one. It needs a lot of work, but what I can do is I can export this as an SVG. I can also do it from the menu.
Or PDF or whatever you want SVG.
Yeah. So you want SVG, and the reason is that's closer to like an image file, right? So I'm going to export this guy as an SVG. I'm just going to put this in my downloads and call it test. So this is my test.svg file.
Yeah.
Problem is, if I go back over to here, say I want to insert it in here. Let me get rid of this guy. So insert image, upload from computer. So I'm in my downloads folder, and I don't see my SVG files, right? Because it's not a supported file type.
Yeah.
So the problem is I need to like convert it. Linux has a really easy way to convert these things.
But then, okay, but why didn't you then export as another format like PDF?
Well, or PDF doesn't work either. This doesn't take. It's not an image that it recognizes. DXF is another kind of weird image that you'd have to do. you could like open it up with Microsoft Paint or like the
Yeah.
Paint thing in here. Linux has like really cool little programs that you can just
Yep. RSVG convert.
install.
Okay. Cool.
Yeah, and this one is like a test.svg. We're going to output it to test. Oop, I need to put it in the right folder. Downloads. Test dot. I'm going to convert it to a PNG file.
Mm-hmm.
All right, so now I have my PNG file there. I'm going to test PNG. And if I go to my docs, I can
Yeah,
insert
and then the
that.
other simple thing you could do is just use screenshot from your FreeCAD window, right?
Yeah, you could do that. You're going to get your background and everything like that,
Yeah.
so it's not going to be super clean.
Yeah.
This is like a really clean image with like a transparent background and whatnot.
Yeah.
So if you wanted to, you can mark this up too
Yeah.
on your page. But so there's lots of other cool stuff that we can do with that. But I figured I spent a few hours on this guy, so I figured I'd show it to everybody else in case you guys were interested in looking at it.
No, okay, definitely. But I still say when we get the computers up in the workshop, we're going to try to install FreeCAD 16 on them too, so people could just do the simple.
Oh yeah,
I mean, we got to start using it. Like, I have to boot up into a different system if I want to do FreeCAD 16, and it's kind of inconvenient. So yeah, we'll have to start using this too.
Yeah. Anyway,
Absolutely.
so that's if anybody wants to play with that, go for it.
Great, thank you. That's quite useful.
Oh yeah, for sure.
Absolutely. Anybody watching this, yes, anybody watching this, learn it and do some of these modules. Love it. Keith, thanks. What a heroic effort. Wow, not easy, as we said.
It's a labor of hate. That's all. That's what it was.
Okay. Well, thank you so much. That's great.
Yeah.
And yeah, so we'll. I think we'll. Jackson.
Jackson hasn't. Yeah.
So I've been working. I think I'm kind of close to cracking the automation side of it.
Oh, nice.
So there's a few tools that I've found. One of them is called Google Anti-Gravity. I'm not sure. I think we want to stick towards more like open source, free sort of stuff.
Mm-hmm.
So I found a tool called Aider Desk, and basically it just allows you to use AI to sort of like automate tasks and have AI working autonomously. The thing that I've run into is I've sort of been using Olama, which is a like an open source like self-hosting tool for using AI. The problem is I'm running it on my computer, and so all of like the really small models don't have what's called like tooling, so they can't do like the autonomous stuff. You have to use like the really big models that they have. So most of the stuff is like paid. So I'm sort of at a crossroads where it's like I'm sort of picking between like who do I want to give my money to more or less.
Well, Jackson, you know what? Let's meet up this weekend if you have time, and I'll show you the process that I have going on, and we'll try to figure out if there's a nice common ground. I'd prefer if we could get through this without spending a dime, honestly. So let's look into that. But I'm also going to do everything kind of manually to start with, because we don't need to automate before we start any of this stuff.
Sounds good. Yeah.
Cool.
Okay.
Awesome, man.
Awesome.
I'll see you later.
Okay. Well, thanks a lot. So anybody watching this, start practicing, generate some tech drawings, and the world will be a better place. Okay. Thanks, guys. We'll talk to you soon. Bye-bye.
Thanks, guys.